Welcome back. Let's do another weak acid problem. This time we will do number 2. All right. What is the Ka for a solution of 0.1 molar acetic acid if the final pH is 2.87? Now, if you'll notice, I'm asking for a Ka right here. Isn't it just 1.8 times 10 to the minus fifth? Well, it could be if it was 25 degrees, but this is implying that these conditions, this final pH, it's not going to turn out to be that way. All right, so let's check. Step number 1, do I have a balanced chemical equation? All right, so it is acetic acid, so I'm going to do the ionization. And I know the Ka is the proton times the acetate all over the HAC. Now, normally I'd ask right here, ooh, don't I know that? But this question is specifically asking for it, so there must be something nifty about it. And do I know any of my starting concentrations? Let's see, 0.1 molar. From the question, it said I started with acetic acid. It didn't say I put anything in it. So my change, but it does give me a final pH. And final in this case means equilibrium. And if I have a pH, I have a proton concentration. So 2.87 is equal to the negative log of the proton concentration. Multiply both sides by a -1. Take the anti-log of both sides. And my proton concentration is 1.3 times 10 to the minus third. Now, this is not X. This is actually the proton concentration or the final proton concentration. And let me see, I had 2 after, so I get 2 total sig figs. And I'm going to plug that in up here. Okay, whoops. I put that under calculated, but in this case, I also know X, because 0 plus X equals 1.3 times 10 to the minus third. So X is also 1 times 10 to the minus third, which therefore makes this one. Oh, well, guess what? This is 0.100 minus X, and I can do that calculation as well. 0.1 is 0.0987, and I get to keep 3 after, so 0.099 molar. All right, I have filled out my table. What in the world was I looking for? I'm looking for Ka, and so I'm going to plug them in, because those are all equilibrium concentrations now. So it's 1.3 times 10 to the minus third times 1.3 times 10 to the minus third over 0.99. So my Ka is there's supposed to be a 0 in there, 0.099. Is 1.7 times 10 to the minus fifth. All right, let's compare the Ka on the sheet is 1.8 times 10 to the minus fifth. So this must have been done at 25 degrees or roughly. Okay. Oh, interesting. All right. That's the way that you would actually find the K value, but I had to give you at least one of the equilibrium values. All right. Until next time, Jolly out.